गुड मॉर्निंग क्लास। तो आज हम देखेंगे इलेक्ट्रो एनालिटिकल टेक्निक्स। तो इलेक्ट्रो एनालिटिकल टेक्निक्स वी आर डिस्कसिंग इंट्रोडक्शन, थियरी पार्ट एंड वर्किंग प्रिंसिपल एंड इट्स एप्लीकेशन। इसमें आपको वोल्टामेट्री एंड polarography, potentiometers, etc. you see in the portion of electroanalytical techniques. So let's start. First of all, the instrumental techniques like potentiometer, voltameter, and conductometer and electrogravimetric. In all of these techniques there is interactions of electricity with matter, and in all the above mentioned techniques we measure the electrochemical properties like potential, current, charge, etc. With help of different instruments like potentiometer, pH meter, conductometer, voltmeter, etc., the use of electrical measurement for analytical purpose has found large range of application, including analytical, environmental monitoring, and industrial quality control or biomedical analysis. Why electroanalytical chemistry? So electroanalytical method has certain advantage over other analytical method, and electrochemical analysis follow for determinations of different oxidation state of element in a solution, not just the total concentrations of element. Electroanalytical techniques are capable for producing exceptionally, exceptionally the low detection limit and the evidence of characterizations informations including chemical kinetics information. Other important advantages it is low cost. As instrumentations used in electroanalytical techniques and the electrochemical cell. Electrochemical cell oxidation reductions or redox reactions take place in electrochemical cell. There are two types of electrochemical cells: spontaneous reactions occur in galvanic cell and non-spontaneous reactions occur in electrolytic cell. Both type of cell contain electrodes where the oxidations and reduction reactions occur. Hence, oxidations occur at the electrode termed the anode and reductions occur at the electrode called the cathode. So इलेक्ट्रोड और चार्ज का डिस्कशन करेंगे तो इंटरफेस थ्रोट विद इलेक्ट्रिसिटी एक्सचेंज विद इलेक्ट्रोलाइट सॉल्यूशंस इज कॉल्ड इलेक्ट्रोड. There are the two types of electrode, anode and cathode. The anodes of electrolytic cell is positive. Anode of a electrolytic cell is positive since the anode attract anion from the solutions. However, the anode of galvanic cell is negatively charged, and since the spontaneous oxidations at anode is the source of the cell and electrons or negative charge, the cathode of galvanic cell it is the positive terminal. In both galvanic and electrolytic cell, the oxidation take place at the anode and electron flow from anode to cathode. It's a simple terminology: flow of electron anode to cathode, and it's a specified for galvanic cell. It's a right side we are mentioned salt bridge and zinc. It's called anode. Anode having negative charge and cathode having positive charge. It's a copper plate, and the both figure between the with one of the salt bridge. The next one is the galvanic and voltaic cell. Redox reaction in galvanic cell is spontaneous reactions. For this reason, galvanic cell are commonly used as battery. Galvanic cell reactions supply energy which is used to perform work. The energy is harnessed by situating oxidation and reduction reactions in separate container, joined by apparatus that allow current. Sorry, joined by apparatus that allow electrons to flow. A common galvanic cell is the Daniell shell shown below. Electrolytic cell, the redox reaction in electrolytic cell is non-spontaneous and electrical energy is required to induce the electrolysis reaction. An example of electrolytic cell is shown below, in which molten NaCl is a electrolytes to form liquid sodium and chlorine gas. The sodium ion migrate toward the cathode and where they are reduce the sodium metal, and similarly chloride ion migrate to anode and are oxidized to form chlorine gas. This type of cell is used to produce sodium and chlorine. The chlorine gas can be collected to surround the cell, and sodium metal is less dense than the molten salt and is removed as it falls to top of the reaction container. Electrolytic cell, they mention the diagram of electrolytic cell. क्लासिफिकेशंस ऑफ इलेक्ट्रो एनालिटिकल टेक्निक्स की बात करें तो इलेक्ट्रोकेमिकल मेथड्स में बी स्प्लिट अप इनटू two major class, potentiometric and amperiometric. In potentiometric, the electron transport reactions is kinetically facial, and we measure to potential of galvanic cell under conditions of zero current flow. The cell potential respond to changes in activity of analytes species present in solution in a well-defined manner described species. It's the analyte species that's present in solution in a well-defined manner described by the Nernst equations. Indeed, the cell potential varies in the linear manner with the logarithm of the analyte activity. In empiriometry, the kinetics of electron transport, empiriometry, the kinetics of the electron transport reactions will have to be drawn by the applied potential, and so we measure the diffusion control current flow across the electrode solution and interface. The current is directly proportional to bulk concentrations of electrolyte present in the solution. टाइप्स ऑफ इलेक्ट्रो एनालिटिकल मेथड, इलेक्ट्रो एनालिटिकल मेथड की बात करें तो इंटरफेशियल मेथड एंड बल्क मेथड, static method and dynamic method is are included in interfacial method. Interfacial method in static method is potentiometry and potentiometric titration. डायनेमिक मेथड में कंट्रोल पोटेंशियल एंड कांस्टेंट करंट, कंट्रोल पोटेंशियल में कांस्टेंट इलेक्ट्रोड पोटेंशियल, कैलोरीमेट्री, वोल्टामीटर्स एंड एपीरियोमेट्रिक टाइट्रेशंस एंड इलेक्ट्रोग्राविमेट्रिक बात हो सकती है, और उसके बाद कांस्टेंट करंट में कैलोरीमेट्री टाइट्रेशंस एंड इलेक्ट्रोग्राविमेट्री हो सकता है. बल्क मेथड में कंडक्टोमेट्री एंड कंडक्टोमेट्रिक टाइट्रेशन. पीएच मीटर की बात करें तो यूनिट ऑफ मेजर दैट मेजर्स द acidity or alkalinity of the solutions using logarithmic scale with 7 as neutral, where lower value are more acidic and higher one are more alkaline, is known as pH. The pH equal to negative log 10 as the hydrogen ion concentrations given in the mole per liter C, and pH is equal to minus log 10 H plus. H plus is solution hydrogen ion concentrations expressed in mole per liter. In an aqueous solution, the product of hydrogen ion concentrations and hydroxyl ion concentration is constant. The pH equal to the negative logarithm of concentrations of hydrogen ion. The pH meter is a statistical tool that monitor the hydrogen ion activity in water-based solution, determining acidity and alkalinity represent as pH. Its measure pH on scale 0 to 14. Proportions of hydrogen ion H plus in H plus to hydroxyl ion OH minus and determine the substance pH value. If the concentration of H plus exceeds that of OH minus and substance is acidic, the pH level is below 7, the substance is neutral, is the concentration. If the concentrations of H plus and OH minus are equal, the pH value is 7, the substance is basic. If the H plus concentrations is lesser than OH minus, this pH value is higher than 7. The concept of glass electrode was first introduced in 1909, Nobel Prize winning to German chemist Fritz Haber. This is a Fritz Haber. This is also scientific name. We are discuss if the referred potentiometric pH since in so different electrical potential between pH electrode and reference electrode monitoring the crucial in area like manufacture of specific food and culture medium and chemical solution soil quality control etc are just few areas where pH monitoring is crucial. Principle of pH meter. The working principle of pH meter relies on the ion exchange from sample solutions to inner solution pH 7 buffer of the glass electrode via glass membrane. A pH meter has pH probe to conduct electrical signal to pH meter, which then display the pH value of solution. The pH probe contains two electrodes, namely a sensor electrodes and reference electrodes. One is filled with pH 7 buffer and other with saturated potassium chloride solution. Sensor electrode bulb compress porous glass membrane coated with metal salt and silica. When the probe is submerged in sample solution to measure the pH and hydrogen ion buildup around the bulb and take the place of the metal ion, and similarly some metal ions transfer from glass electrode to sample solutions because of low sensitivity of pH changes or complete insensitivity to pH changes. The reference electrode potential offer a constant voltage. This generates some electricity captured by the silver wire by generating potential different hydrogen ion activity. The pH meter convert the voltage of electricity flow into pH value by comparing the generated voltage to reference electron. Increasing solution acidity result in higher concentrations of hydrogen ion, which rise the voltage, and pH measure on pH meter decrease due to increased voltage. Increase the solution acidity result in higher concentrations of hydrogen ion, which rises the voltage. The pH measurement on the pH meter decreases due to increased voltage, and similar to how an increase in alkalinity reduced to hydrogen ion and increase in the concentrations of hydroxyl ion also reduce the voltage and arise the pH reading on the pH meter. Thank you for watching my videos, and we continue next part for electroanalytical chemistry.